All right. We're going to look at record types, not all of them, just some. I don't have enough time to do them all. We're going to look at recursion and how it happened for a simple scenario. Then we're going to do a more complex scenario. We'll look at redirects with the Cname record type, and then we'll look at a zone transfer. All of these files were taken at the DNS server, not at the client, at the DNS server, just to let you know. Okay, so let's look at record types first. Pop open Wireshark here. There we go. And get that out of the way. There we go. So I want to go ahead and look at the record types. I want to kind of do it backwards though, because they're showing up how they happened, but that's not how I want to cover them. So I want to do the easiest one first. So I've got a standard query for Yahoo, right? Packet number 9, okay? And client went ahead and, so the 47 dot is the client, went ahead and sent that DNS request to the local secondary. I went in and gave everybody a name for all of them, and I saved it, so they should be in your file as well. But if not, how I did it was you just, pick an address, right? And you say edit resolve name, and then you put in, whatever name you want it to have. So we'll call this one an external client. There we go. And when I exit the file, it's going to ask me, hey, do you want to save that? And then it saves that information with the file, which is great. Okay, so that's why I have names. So we've got a nice little external client, wants to go to Yahoo. All right, apparently they're, living back in the 70s or something, and did a query to our DNS server. Now, there we go. So my DNS query. Now, if you look down in the DNS, pardon me, DNS section, we've got a query for yahoo.com for an A record. So an A record is an IP4 address. If it had been a quad A record, 4 A's, then that would be I'm looking for an IP6 address. Now, I don't know if y'all have noticed this or if you ever sniffed yourself doing DNS, but if you've got both stacks bound, both IP4 and IP6, you actually ask everything twice. So if I want wireshark.org, I'm going to send 2 queries, one with an A record for IP4, one with a quad A for IP6. Now, let's say I get answers back, right? And I get both IP4 addresses, and let's pretend for wireshark.org, there's also IP6 addresses. So I get an IP6 response. You're going to want, my Macintosh is going to want to go to that IP6. So is Windows. All right. So even though you get the IP4 answer first, you still want to go to you still want to hold out for that IP6. So if you never use IP6, there's that wait time, waiting for the IP6 response that says, hey, there's no such IP for this name, but you had to wait for it before you could move to the next step. It's all these little things. Okay. So I've got my A record, right? And then the class is IN for internet, okay? Now, if I go ahead and I look at the response, now I know that it's the response if, here, let's see if I can do this. Think positive thoughts, right? And yay, it worked, okay? Y'all notice on the left-hand side, those arrows coming in, coming out, right? So Wireshark goes ahead and looks for, in DNS, looks for the transaction ID. That's how you correlate the command to the proper reply. Think about yourself for a second as the client, and you're surfing the internet. You're like clicking on new tabs like there's no tomorrow, right? And so you're sending many, many DNS queries at the same time to the server. Well, when the responses come back, how do you know which one to put with which? Well, when you did the query, you gave it a transaction ID, server responds using the same transaction ID. And that's how it works. Now, so my response comes back. it took a little while. I'm just saying, 6 seconds, okay? Now, I took this PCAP at the client, at the server. I know that the server did not do any packets in between those 2 packets, as far as for this process. It didn't do like recursion and stuff like that. It literally was an answer from cache that took 6 seconds. Okay, now, so that secondary has had its challenges. Now, but he did answer, all right? And if I come on down into the response, there in packet 10, so I've got my A query, all right? And when the response comes back, I have an answer that is a Cname record. So there's my redirect. So what's happening is you don't really go to www.yahoo.com, okay? People don't have their own servers anymore. When you're going to big pages out on the web, your Googles, your ESPNs, your, whatever, I can't even think of another big web page. But when you're going to those, they're not in-house, okay? And so what happens is you get, hey, that's really a different name. So that is a canonical name, a Cname. It's funny, the first time I saw that in a DNS packet, I don't know, 20 some years ago, I was like, I don't even know what the word canonical means. And I had to look it up in a dictionary. And it means, the real name or the true name. In other words, the real name for an alias, okay? And we're allowed to cache that for 52 seconds. And that's what the time to live is. And the canonical name or real name is new fp shed wg1b.yahoo.com. All right. And for that name, here are 4 IP addresses. Feel free to pick one. Okay. Now, when you send multiple DNS, if the server goes ahead and sends multiple answers to a DNS response, clients, real clients, not like DNS servers acting as clients. We're going to talk about that in a second when we talk about recursion. But real DNS clients, they go ahead and, as far as I've seen, only like 2 or 3 times in my whole career have I ever seen a client not take the first one in the list. Okay, client's got it, off and running. Now, DNS servers, on the other hand, when they're acting on the client's behalf, they put everybody puts the whole thing in cache, but they might pick any one of the multiples to make their next request. Okay, it's just all depends on, the DNS software that we've got in our operating system, okay? Okay, so I've got, 4 addresses all set to go. If I had kept the TCP SYNs in this trace file, you would have seen a TCP SYN to the 98 address. Okay, we're off and running. Standard, regular, except it took forever. Okay, response. Okay, so then I want to go ahead and look at a name server record. Okay, so if I scroll over a little bit, see how some of these say NS and NS? That means name server. So what I want to do is click on packet number 1, and we're trying to do a query for research scan 541 Echo Echo Charlie. I don't know what the S word is, and then universityofmichigan.edu. Okay, and we're going ahead and we're asking for another type of record. Okay, and that one's down, and so I got a regular query looking for an A record, looking for an IP4, and then I have an additional record, and I'm asking for a root request or an OPT. Okay, and what that means is, and we're going to look at this in depth in just in the next trace file, but the next example. But what it means is, hey, I'm sending this to, an authoritative server, and I'm asking. So if I do a root record, I'm asking for a response from whoever I ask for of whatever label they're responsible for, please give me authoritative answer. That's what a root record request is, or an OPT record. So we've got, here, let's make this a little bit wider there. Okay. So I can see the whole thing. Okay. So we've got in this, request, we've got a couple labels. So let me turn my marker on. There we go. And research 541, that is a label. And then echo CS is a label. Pretty much everywhere where the dots are is a label. Okay, that's what the labels are. Everything in between the dots. And so whoever we're sending that to, we're saying, hey, you might be responsible for all of the EDUs, and I'm looking for the University of Michigan. Or maybe you're responsible for the University of Michigan.edu, and I'm looking for EECS, or I'm looking for the authoritative server, for EECS, University of Michigan.edu, and I need to find this host name. That's what they call it. They refer to them as labels, okay? So when you see that, realize you're about to start recursion, okay? Now, when the response comes back, oh, and let's see, who did we ask that of? Okay, we did our standard query. In fact, I'm gonna go ahead and focus on just that standard query. And so what I wanna do is I wanna filter for the transaction ID. Now, I could go ahead, click on that. I could go ahead, come on down to the DNS header, grab the transaction ID and, drag and drop it and put it in the filter input bar, right? Okay, and that's super cool. Love that, okay. Or I happen to have a filter ready for you because that's how I am. And it's called the DNS transaction ID filter button. Now, I'm gonna hold still for a second. I want you to look at the syntax for that. It says DNS.id equals, oops, and then it disappeared. I'm gonna click on it. There we go, so we can see it up here. So DNS ID, that's the transaction ID field, equals, and then $sign DNS ID. So what those filters do, and you can do this for any field, okay? But what those filters do, I call them a context sensitive filter. I don't really think that that's actually the name of it, but that's what I call it. And what they do is whatever packet you're on. So if I'm clicked on packet number 7 and I hit that button, I'm gonna get a totally different answer, all right? So it takes whatever whatever packet you've clicked on, whatever transaction ID is in that packet, filter for all the packets that have the same transaction ID. And that's what the $sign means with the curly brackets. So, pardon me. So our local secondary went ahead and asked 192.33.4.12 for this answer. And the one that comes back for the answer is the A root. So not sure why the name didn't pop up right there. But for this one, I got a different IP address, and it's the alpha root server. Now, so an authoritative server. Okay. And let's see what the server says. We've got 15 authoritative records, and that's the whole goal. We wanted to know who's the authoritative server for this big old long name. And then we had 27 additional records. So we're just looking for an IP4 address, and one of the name servers is alpha, eduservers.net. We also have one for Bravo. Okay. We also have one for Charlie, right? We also have one for Dixie. Okay. So, we've got a whole bunch of different name servers in the list. Our DNS server is going to go ahead and put that all in his cache. And then if I scroll down a bit more, all right, so that's where the NS records are coming from, name server record, authoritative name server. And then if I come down, I want to look at the additional records, and then this is exactly what it should be. When we come back with all of those names, we should also, the DNS server should give a nice, beautiful IP address for each one of them, if the world is perfect. All right, that's the goal. So we've got lots of different IP addresses for those servers. So our, our local DNS server would put all of them in his cache. And then when clients ask the DNS server for, that name, he'll go ahead, depending on how he's set up, right? It all depends, because, you got your Microsoft DNS servers, you got your bind DNS servers, which is what it should be, in my opinion. But either way, we could go ahead and look at those, IP addresses 1, 2, 3, 4, 5, 6, 7, and just do them in order every single time. But that means you always go to number 1 first all the time. That doesn't feel good, right? You're hitting the same one all the time. That should go, your mind should go, ooh, right? So what we also can do is go ahead, 1, 2, 3, 4, 5, 6, 7, and then put 7 on the bottom. Everybody comes up. And then, 2, 3, 4, 5, 6, 7, 1. And you hit 2, and then 2 goes to the bottom, okay? That's called round robin. Love that. And then some DNS servers can be set to go ahead and just randomize them every time. So it all depends what address my server is going to give out, but at least now we have all of those addresses and names in cache. Yay. Okay. Oh, and we get to keep these for like 2 days. That's nice. So you can, whoever sets up the zone gets to decide. So I set up the zone for BettyDuBois.com. Right, I set up the DNS zone. And so for different records, sometimes people give different time to lives. Sometimes they give the same time to live for everything. It just depends on who set it up. So I have, for mine, I have the same times for everything, okay? But you can do it by different record types. A records could have one value. However, pointer records, where I'm doing the query inversely, I have the number and I need the name versus I have the name and need the number. Maybe I have that at a shorter time to live. It's just whoever set up the zone. You'll see time to lives of like a second, okay? Oh, and by the way, time to lives are a guideline. They're not gospel, alrighty? So, a lot of people think that, oh yeah, that's, it's gonna age out at 2 days. It depends. Okay. Windows loves to keep stuff in its cache. And then, ISPs, who have DNS servers, sometimes they keep stuff longer in cache to make, their lives easier. So, it just depends.
Betty?
Yes, sir.
In regarding to time to live, there was a question from Karl Klatsky about for the time to live. Is it always the case that the A record response and Cname response have the same time to live?
No. So that is not always the case. That's the most usual, but it is not an always. So like I said, maybe I have a Cname record, very, very small, very, very tight, because let's say I'm farming it out to a content provider, like a CDN. And, those servers, which server I'm going to use, we use different software to determine what those should be. So maybe that Cname is really, really small, but the servers themselves, maybe their IP addresses, stay the same forever. And then, so that might be much bigger, just it totally depends. Cool. Okay. And then, all right. So, NS records. So the beauty of the NS records is now I know what server told my server that these were good addresses. So it came from Alpha Root. I can pretty much, feel good about that. If it came from some weirdo DNS server, like an authoritative server from weirdo label name dot weirdo, extension like, XYZ, it's not a good extension. Then I might want to look, where did that come from? All right. So, okay, now, there we go. Okay, then let's go ahead and clear that filter. Then I want to filter for, I want to look, so we looked at the name servers. I want to look at the SRV records. Okay. Now, an SRV records, what that's for is for a service. All right. So if you look at all the record types, there's one application layer record type for the email server. That's the MX record. And then they realized, okay, if I give out a different application server record for every single application, DNS will not be as fast as we want it to be. All right, we should have done that. So let's go ahead and use SRV for all the other servers. And that's why it works that way. And then, so what, when I get my, DHCP, right, my server tells me who the DNS server is. He doesn't tell me who the LDAP server is. Doesn't tell me who the Kerberos server is. Doesn't tell me who the SIP server is. These are all things that I need to know. So I go to the DNS server with an SRV request, and you see how what we're querying looks kind of a little bit weird. And Roland, I don't know if that's you or if it's Angelo, but I can hear the keyboard, if you don't mind.
Sure.
Oh, hey, no worries. Okay. And then, so the name that I ask for is _ that just gives it right away. And then you have the name of the protocol. Is it going to be on TCP or UDP? And then you go ahead and append your domain search name. And that's how they look, okay? And of course, I do not have an SRV server, so it comes back with an error message. So when I look at packet number 4, my error message is in the flags section. And so the reply code is no such name. When it works, it's all zeros. When it doesn't work, back on packet 4, it says, something besides all zeros. So if I want to look for all of my error message packets, I go to the response filter button group, and hey, everybody give a shout out to Roland for setting those up. He had help, but I think it was his idea. You just go ahead and do a filter for errors. I'm going to hold still on that. And it's DNS flags.response code not equal to 0. And then for quad A's, quad A records are a little passive aggressive. It's kind of weird. So a quad A server will not come back with a no such name. It will come back with, here, let's put the filter in. It'll come back that, hey, we got a response and for a quad A record, but there's the bang for not, there's no quad A records, which is all of these responses, okay? And that's how you say no such name in quad, in IP6. So I think that's a little passive aggressive. Okay, so those are a couple different record types. Now, let's go ahead and look at a recursion lookup. So I'm going to go ahead and pop open file number 2, right? File number 2, blah, blah, blah. And let's look at that one. Oh, do you want to continue without saving? So this is what I meant where, hey, I added a resolve name to the file. And that's why Wireshark's saying, hey, don't you want to save that? And I'm like, yes, I would love to say that. Thank you for asking me. Okay, so I got that one saved, popped open the new one. Now this one's got a chance for us to look at recursion. So packet number 1, we've got a client who's looking for Bing. Now here, let me go ahead and make this a little smaller so we can see more at once. Here we go. Cool. Yeah, that's what I want to see. So I've got my client goes to my primary DNS server and is like, hey, I want to go search something on Bing. I need an IP address. All right. Server goes ahead and looks at that request and says, ooh, let's see if I can get my thing out. There we go. So I don't have that in my cache. I don't have the whole thing in my cache. Bummer. So then what he has to do is go, okay, I don't have WW. Do I have an authoritative name server in my cache, right? Those NS records. Do I have that for bing.com? Okay, look through cache. Nope. All right, bummer. So then what we have to do is go, okay, well, I should have .com servers in my cache. So we're just moving labels. We're starting from the left, working towards the right. Okay, so in com, do I have one of those, authoritative servers for .com? And usually a DNS server would have that in his cache, okay? Because he's getting so many requests all at one time, right? But let's say our server, it aged out. Actually, I had just bounced this box, so he had nothing in his cache. So let's say that aged out. Now we've got to go to the teeny tiny little dot that nobody sees. And there we go, try that again. There we go. Little dot that is at the end, at the very, very end, that is really there, even though you don't see it, it's really there. And that is the root, okay? So we're gonna have to go all the way up to the root. We're gonna have to ask the root for a com server, then look at all the IP addresses for the com servers, pick one, go ahead and ask one of them for, hey, I need an authoritative for Bing. Then once I get an answer for that, then I gotta go to that guy and say, hey, I need a WW. So this is where we're gonna go. Now, server goes ahead, sends out a question to 4090.4.204. Now that's not a root server. How do I know that? Well, because I have a filter for all of the root servers. So I have one for IP4 and IP6, and then I have them for both. Okay, so that, my friends, is a serious filter. Okay, so I'm just gonna do this filter for right quick for IP4 because I think I named all the primaries. Okay. Oh, hey, this gives it away. It's Microsoft's autonomous system number. So it's a Microsoft, it's an Azure server. Okay. But I could go ahead, hit my filter. I have no packets. Boom. I know that that's not a root server. Okay. So my source is coming from Microsoft. So he's asking on his DNS, his upstream neighbor, right? So I've got all these servers up in Azure, and he goes ahead and asks, hey, I want, www.bing.com, but I got that OPT record. I got that root record. So that I'm really asking for whatever label you're responsible for. Might be the dot, might be root, might be the com, might be the Bing, whichever label you're responsible for, I need an authoritative server for that. And then, so there's my root record, okay? And then he also asks for, needs some information on DNSSEC. I do not have time to talk about that, but that's what that is. All right, so let's see what the server says. Server says, and I'm gonna collapse that in the flags, there we go. In fact, I'm gonna collapse everything. There we go. So I can see this a little easier. There we go. That lays out nicer. So in the response, you ask for a root record and you ask for Bing.com, okay? Now, that's really an alias. The canonical name is alpha001, blah, 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 trafficmanager.net, which is, a Microsoft address, okay? And so the DNS server looks at that and goes, I don't know that in my cache. Oh my gosh. So he goes ahead and asks, and it's a .net, so he can't go back to the .com server and say, hey, I need an authoritative server for trafficmanager.com because it's .net, right? So he's got to go to a .net server. And he did have one of those in his cache. So he goes ahead, asks for the A record, asking for root. So servers know, I really want the label, all right, for that label. I need an address for that label. And the response comes back and says, okay, so alpha 001, blah, 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 traffic manager, that's an alias, of course. The canonical name is, Bing, blah, 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 msedge.net, right? And you notice that in the answers and in the additional records, you notice these servers are not giving IP addresses, right? And, so they do not have what the, for the canonical name, they don't have an IP address. When we looked at Yahoo, that person had the IP addresses for the canonical. So it just depends on what they have in their cache. They're not the authority for that particular domain. They're the authority for for .net. Okay. So poor little server has to go ahead and ask one of the .net servers, like, hey, I need bing.com, blah blah blah, MS Edge. I need an IP address for that. And then the response comes back and says, why, yes, I have those 2 IP addresses. Okay, here you go. And then now the server can go ahead, finally, all right, and send that information back to the client. So the whole thing took about 8 milliseconds. Not too bad, all right, to do all that recursion. If you go ahead and come up into statistics and come on down to flow graph, there you are. Perfect. And, okay, so then you can see the whole flow. All right, so I had my query to Bing. Notice that my highlight moved. I don't know if you guys noticed that or not. So when you click on these, all right, it moves over here, okay? And so it's just sometimes it's easier to see in a visual, and which server did I go to first, then who did I go to next, what information did they give me to go ahead and give me the next step. If they'd given me IP addresses, our DNS server wouldn't have had to do those extra steps, but those authoritative names didn't have IP addresses for those servers. Okay, they were outside of the labels for that, okay? Think of it that way. And then finally, we got a reply, right? And I've got, how long it took. Now, let's pretend that this is real life and I have, 80,000 more packets intermingled in here. Well, then obviously my time column right here is not going to be from the first packet, to the last packet involved, okay? It's going to be for, the whole trace file to the bottom of the trace file, right? So what you do is you go ahead and you do the filter part, okay? And let's pretend that packet number 3 was the first in the process. So I would right click on packet 3, set it as a time reference, you ready? And then go ahead and statistics and flow graph, there we go. And you see how it zeroes out for packet 3 and then starts counting from there, okay? And now it's, 6.9 milliseconds. So that's how you would do that. Then if you had to do that, right, you would also have done a filter for just those address, just those packets. And then down here at the bottom, this is kind of a critical thing, limit to display filter, because trust me, I had about 90,000 packets in this trace file, okay? So I kept saying limit to display filter. And that is in conversations, it's in endpoints. I love that checkbox, right? So then you would see just that one, because if you try to look at a whole trace file and it has 1 million packets, flow graph will freak out. Okay. Now, all right, so that one's good, okay? And that's how you do a redirect with a canonical name, right? So, all right. So next, all right, let's do a little messier recursion, Okay, because you know it's so awesome when people try to go ahead and explain how DNS works and they draw these cool flow graphs, which Wireshark does for me. So I did not do one of those, and they go ahead. It's like so perfect, right? There's like we ask a root server, and then you know we get a COM address. We ask the COM server, and then we go ahead and ask the authoritative server from the COM server. It's perfect. Let's look at the next trace file. Okay. Let's look at real life. So open up DNS recursion. For one query, to respond to one query, it took 31 packets. Okay. Now, let's talk about what happened. All right. So remember, my poor little server does not have anything in its cache. Bless his heart, I bounced him before I did all this stuff. And sometimes people don't realize what I mean when I say bounce. For me, a bounce is a power cycle, okay? And that, because when in doubt, bounce it out. Okay, now, just a little thing from your Aunt Betty. All right, now I've got a query for wireshark.org. All right, this is my goal in life, to go and download a fresh copy of Wireshark, because you know, hey, that 3.5, you can actually download that now. All right, I'm sure Gerald brought that up, but you can download, you know, development versions. You don't have to wait for it to release. Go for the beta stuff, man. It's fun. All right. So then we did a query, okay, and server's like, I don't have Wireshark.org. I don't have an authority. I don't have Wireshark.org. Period. I don't have an authoritative server for Wireshark.org, and quite frankly, I don't have an authoritative server for org. I'm going to have to start from scratch. So he goes ahead and he asks the H root. Now, I put in the Zoom one links to a list of all the root servers. Sometimes people refer to them as root hints because that's really what they are. You know, when you install bind, right, you have to put in this list of root hints. Then, or if you install DNS server on a Microsoft server, got to install, it doesn't call them hints, but you still have to install the root list, okay? So that's hard-coded, you know, that's in the server. When they boot up, it's loaded into cache. So that this stuff is in the cache, okay? And remember, we might go ABC, we might do random, we might do round robin, okay? And so our DNS server is like, hey, H is, you know, H, I can't remember what the word is for H. I forgot. All right, so there's some word for H. Okay. And then it goes to that server first. We get a response. Okay. Now, in the responses, let me bring this up a little bit because there's a lot of stuff in here. In the responses, yay, no error, so that's really good. And here are the authoritative servers for .org, because that's really when our server, our local primary, did its request for Wireshark.org, it had a root record, right? And that's why Wireshark says OPT right here, okay? So he's really asking for, hey, you know, for the label you're responsible for, what's the scoop on that? And server comes back and he's like, yeah, here's all the org servers, right? Now the COM server list is really long, but here, let me flip. There we go. But the org server list is actually, this is it. So everything in the packet, that's it, all right? And so we go ahead, give you the whole list, and because that server, you know, the H root server, super duper awesome, he has IP addresses for all of them. Awesome. And then for some, there's more than one IP address. Hooray. Okay. So my server goes ahead, puts that in his cache. He's going to pick one of these and make the next request. So he goes to charlie.org, right? And says, hey, OPT, I need the label you're responsible for. I'm looking for Wireshark.org. You know that what I really mean is I need an authoritative server for Wireshark.org, okay? Server comes back with, why, that's Olga over at Cloudflare. And, you could ask Cody as well. I love how Cloudflare names their servers. I love it. It's perfect. So, you can ask Olga or Cody, right? And then this other stuff is IP DNSSEC stuff. I don't have time to talk about that. So we're going to focus on these two addresses. Pick one, run with it. All right. Now, so meanwhile, our poor little client is going, dude, man, could you give me wireshark.org? Right? In fact, let's go ahead and hit our DNS transaction ID on that. And I want you to notice that the client asks and waits patiently and then asks again at about 29 milliseconds. What that means is we only have one DNS server, okay? And so, because we repeat the question to the same IP address. If we had a different, like if we had a DNS, like, in our DHCP scope, if we had, like a primary and a secondary, maybe, like 5 secondaries, however many DNS servers we have, then we would go to the next DNS server. We would go to the secondary. And then if we didn't get it, we would go to the ternary, all right, et cetera. Okay. So that tells me only got a primary, right? And so we go ahead and we ask again, poor little client. Okay. Notice that Wireshark says retransmission true. Wireshark tracks the fact that same transaction ID, same IP addresses involved. I see it more than once, retransmission. Okay. And then bless that client's heart, it's like, okay, haven't got a response yet, so I'll wait a second and try again. Okay. So first time we back off, that first timer is actually kind of variable. I kind of see like 30, 20 to 30 milliseconds, depending. Okay. Then the next one, we go ahead and wait the full second. All right. Wait another second. It's like, hey, dude, seriously, Wireshark. Then don't get an answer. Go ahead after 2 seconds. Seriously, dude, I need Wireshark, right? And then, almost another second later, finally, I'm like, oh my gosh, this is so great. I finally have IP addresses for Wireshark. I'm very excited. There they are. And then I have another one because DNS servers will go ahead and if you ask it 5 times, it'll reply 5 times, even though the information is the same. It's stateless, okay? Because we don't want to keep track, and be stateful because that adds, computation time. And while that's awesome, that if we want to be stateful, the goal of DNS is speed. So stateless, okay? It's the firewall's job to go ahead and protect that DNS server, not the DNS server's job, right? So finally, after 4 seconds, all right, we finally get a DNS response, okay? And we're gonna look at what happened in the meantime. And then we just go ahead and have another one, right? And then another one. Now we don't match, we have 4 queries, server only replied 3 times. We're sniffing on the server, so we know there were 4 queries. It's not like at the client where the client sent 4 queries and we just don't know if they made it to the server. We know, okay, where you sniff matters. Sniff on the server, don't be afraid. And so number 1, we're not replying to 1, so my DNS server is less than awesome right there. And but we do get responses. And then the last one, we get a response, but it says server failure. So that's a different error response. So what a server failure means is that it's not that our DNS server failed, because that's what it sounds like. Server failure. Oh my gosh, I'm scared to death, right? You freak out when you see that in a PCAP, right? But what it really means is our DNS server tried to do recursion. It asked, the authoritative server and got silence for the reply. That's what it means. Now, when we go ahead and look at the rest of the packets, that's not actually what happened. but that's what it's a, that's what it means. So what that, what that says to me is my DNS server is lying and can't keep track of all of the requests. A little concerned about that box. All right. Oh, and by the way, when I set it up in Azure, I purposefully, in the, provisioning it, I gave it like diddly squat for, RAM and CPU. Okay. Specifically, so these kind of things would happen. All right. I was going to stretch that thing to the max with just a few queries. Okay. So that's what's happening in the background. Meanwhile, server failure. Okay, so let's go ahead, and we were on, I think, we like packet 6. I think that's where we were. Let's go ahead, clear our filter, and okay, so we do a, so client retransmits, right? Then the server, remember, Olga, our DNS server is like, okay, I don't have .com. Authoritative server for .com in my cache. Let me go ahead and hit up alpha root and say, hey, do you have an IP address for Olga NS Cloudflare.com? Okay. Server comes back and he's like, oh yeah. All right. Because I know you really aren't asking about Cloudflare. You're really asking about .com. Here are all the, here are some, not all, of the top level domain servers for .com. Pick one. Okay, and because that a alpha server is uber fabulous, here are all the IP addresses for it, and just for giggles, here are the quad A addresses for it. The IP6 addresses, because hey, maybe you might want to do IP6. I'm just going to give you everything in case you need it, which is awesome. All right, that's why the packet is so much bigger. Okay, then, all right, we're going to go ahead and client asks again. Then our server goes ahead and goes to the kilo for K orgs, top level domain server, and says, hey, I'm looking for Olga, right? And you're an org server, a com server, forgive me. You're a com server, so what I really mean is, because I got the root record, I want cloudflare.com, I need an authoritative server. So server replies and says, well, hey, you got NS35467, for Cloudflare. And by the way, here's some addresses for you. And notice there is an address for NS5. Put that in your buffer. NS5 is in there, okay, with an IP address. So my server should just go to, one of those, servers that we've got an IP address and go ask about Olga. Okay. That's not what happens. My DNS server goes up to the root and asks for top level domain servers for .com again. Now, in the reply for the list of .com servers, the time to live was pretty good size. Okay, so he did not need to do this, right? So he goes ahead and asks Alpha again, same question, and then Alpha doesn't reply as quickly as he wants, and so he doesn't even wait 36 microseconds, not microseconds, and he's like, hey, maybe I'll just go ahead and ask Indigo as well. And then the replies come back. Look how fast that reply came back, right? 27 milliseconds, for Alpha comes back. And it's like, all right, oh, no, excuse me, another query. All right, so we don't wait very long, we ask again. Okay. And so finally, we ask 4 different questions from 2 different servers. Finally, the 4 responses start coming back. I'm only going to look at one. And the server comes back is like, yeah, hey, you asked me for .com servers already. Here is their the list. And by the way, I'm just going to pick one at random. And oh, by the way, you can cache that for 2 days. So he didn't have to ask. Okay. And that means he's having problems holding on to his cache. So get a wallet. All right. Then finally, we go ahead and ask NS5 for the olga.ns.cloudflare.com. I needed an authoritative server for that. The server goes ahead and replies. And what I'm doing is I'm watching that transaction ID. So I know which reply is which, okay? So the response comes back. It's like, yeah, Olga's fabulous. You'll love her. Here are 3 IP addresses for her. Pick one, run with it. So the primary goes ahead and hits up Olga, okay? And they, say might, go into that proper IP address for the name server, because it's kind of funny because that's actually Olga. So NS5 is also Olga, okay? And comes back and says, okay, well, here's those same IP addresses, right? And then, okay, so now we know the IP address of Olga. And finally, hooray, let's go ahead and ask for wireshark.org, right? We'll do a query. We did a query for the actual wireshark.org straight to Olga, and then the responses came back, okay? And the client goes ahead and it's like, seriously, I'm still waiting for wireshark.org, okay? So the server has the information that he needs, right? And he goes ahead and finally, hooray, response. Now, this packet right here is where we have, actually, oops, let me try that again. Packet 26, I'm gonna mark it so it changes color. It goes to black and white. And packet 26, the server has the information that he needs. Now, the time from packet 26, let's go ahead and set it as a time reference, to when the server goes ahead and replies back to the client is 2.73 seconds. So, right. Now, server went ahead and asked Olga, different times, okay, when he didn't have to. And then he held on to the response, the repeat response for, almost 3 seconds. And then he finally went ahead and sent it to the client. Okay. Now, here, I'm gonna time reference that. There we go. That's why, following that flow is sometimes a challenge, okay? And that's why once you got it, filtered for just the flows in question, and I did it, I literally did it based on transaction IDs. So I did a big filter for all the transaction IDs. And if you look at it in a flow graph though, it kind of helps. And that's one of the big reasons I name these. So it's a little easier to follow. Who are we talking to? You're looking for those little arrowheads, okay? Now, one more right quick, because I only have a couple of minutes before Roland tells me I'm supposed to stop. And last one, zone transfer. Pop that one open. There we go. Okay. Now, for the zone transfer, here's what's happening in the background. I'm setting up, so I've already set up my primary server, and I'm setting up the secondary server. And when I do that, I have to tell him I have to tell the secondary who the primary is. As I'm doing that process in the background, okay, before I can even hit okay, the secondary goes ahead and asks for an SOA record of the primary. In other words, are you really the authoritative server? The human went ahead and typed in this IP address, but do you really do that? So let me ask and check. Okay, that's what the purpose is. And if I expand the query just a bit, you see that we are asking the SOA record is start of authority. And so server comes back, my primary comes back and says, yeah, I am the authority for this domain. Let me tell you a little bit about myself. So in the answer, okay, we go ahead and say the name of the domain and that we're the authority. So this is my primary DNS server. And he says, you can cache this info for a minute. So I put in really low TTLs so that they would, flush out a cache right quick. And the name of, my name's going to be 37 bytes long. My primary name is NS4. My responsible authority mailbox, actually people used to put their you know, like their name of who you would contact, you know, when it started 40 years ago, because, you know, what if my list is messed up? I need to go ahead and have somebody contact me to tell me. Okay, that's what that was for. Obviously, you know, now people just put, you know, like I left it at default. Sometimes people actually put some information, but they don't actually put people's emails anymore. And the serial number, what that is the number of my database. Every time I update the database, right, and I add a new record, then the serial number increments. And so my server is going to go ahead and give you the actual serial number. And the purpose of that is going to be that when we do incremental transfers, you know that the information that you got from the incremental transfer is newer than what you already have. Okay. Now, sometimes people go ahead and they don't use that field for that purpose, but that's what it's for. And then, you know, how often do I refresh the information? Every 15 minutes. If I don't get an answer, kind of like DHCP, right? I'll go ahead and try again after 10. Everything expires after a day. Minimum TTL is a minute. Okay. So that's what the server says. And that's the information you get about the authority. Now, so then, you know, so that's the information going on in the background while I'm trying to configure the IP address. So that's exactly what the software wanted. All right. Now that's what bind wanted. And it's going to go ahead and let me move to the next step. All right. So then I put in my secondary, you know, I put in, you know, my secondary knows who the primary is. So my secondary goes ahead and says, hey, I would like all your records, an AXFR. I want all the records you've got. And the response comes back and says, okie doke, for this domain, these, I am the authority, right? And these are all the different records that I have. Two records. That's all I got. And then, but you know, it worked, right? Now, I want you to notice that now we're talking about zone transfers. We just moved to TCP, okay? So when a server is acting on the client's behalf and doing recursion, it stays on UDP just like real clients do UDP with DNS. But now it's zones, it's important. And really the big thing is it could be much bigger than a single packet. In fact, you know, mine's not because my zone's so small. But normally zone would be much bigger than, you know, a single packet. So we need TCP in case, you know, packets arrive out of order, okay? So then server comes back and let's see, 5 minutes later, takes me a while to type. I added a few more records, right? And I hit okay. And so now my primary now has more records. So my primary tells my secondary, hey, zone change notification. It doesn't actually give him the new records. It just says, hey, come ask me for the new records. So that works. And so the server's like, okay. And then the secondary asks for an IXFR, incremental XFR. And that's what he'll ask from now on. And that is, you know, what's the new records? Server comes back, says, I am the authority. And those are the first two that we already had. And then now we've got a SIP server. And I think, and then, yeah, that's all. And a new start of authority record. So 2 new records, okay? And that is a zone transfer. Now, Roland, how am I doing on time?
Well, you have about a minute.
Yay! And I finished. Yay, because I usually only get about halfway done. So
we don't have any questions open at the moment.
Oh,
there is
okay.
a lot of people answered your question about what does H mean. It means hotel.
Oh, right. Oh, thank you. Hotel. You'd think I would remember that, and I forgot. Thank you. Because I really only know up to Foxtrot because that's hex. I know that, like I know how to breathe. But all the other ones, I sort of kind of know some of them, but not all of them. Okay.
And Mark Cut, I think, asked the question chat. So servers do a good job of changing the query destination or load balancing versus clients, which almost always use the first one, which ends up overloading the first one.
Exactly. And that's why servers go ahead and, you know, rearrange so that since clients always hit the first one, they get a different first one each time. All right. And that whole, like, let's rearrange the list, you know, either round robin or random, you know, however we're going to do it. That process is load distribution. It's not load balancing. There's no logic in it. There's no thought process in it based on, hey, how are you doing? You know, you got some availability for a question? No, that's not how that works. It's just like, let me go ahead and rearrange the numbers based on however I'm configured so that you get a different one, you know, each time. So load distribution. Sweet.
Oh, okay. We do not have any other questions at the moment.
Oh, good. That's good, because that means I covered everything. I did want to show all y'all. So these are nice, you know, from Mayana, super fabulous. I like a visual. So if you've ever wondered where all the DNS root servers are, if you go to root-servers.org, this is who the root servers are, okay? So if I scroll down just a little bit, I happen to be in Atlanta, so I'm going to zoom in a little bit there. Zoom in a little bit, and then zoom in a little bit. There I am, okay? And we actually host a couple of root servers in Atlanta. We host the, you know, so, you know, as far as it, they're in a location here in Atlanta, a data center. And we've got Alpha and Dixie and I don't know what L is, Foxtrot, and I don't know what J is, and then Echo Echo. So we have 2 instances of Echo and 2 instances of Foxtrot. All right. So, so what I could do as the person setting up my DNS server, I could go ahead and, you know, I have to put in all 13, but that doesn't mean I have to treat them equally. All right. So what I could do is Alabama's not very far, and they have 5 servers. All right. They're all, each 5 of them is the same as what I have. And then Nashville, I'm looking for ones that have different letters. Maybe Richmond. Richmond, how are you doing? Okay, he's got a Kilo server. Okay, so what I could do is go ahead and give the IP addresses for those root servers that are in Atlanta, and put those in my list and give them. I can weight them. So not weight like wait your turn, but weight like it weighs 5 pounds. And I could give them a different weight that says, hey, go to these IP addresses first, because it's, you know, it's very, very close, right? And then I can go ahead and give the extra addresses, right? So Richmond, okay, I could go ahead and put that in, give it a slightly, you know, different weight so that I go ahead and go to it. Go to Richmond when I need the K server. And that way, and then I just got to find the ones that are closest to me. Okay, so I put in those IP addresses, and BGP is going to determine, you know, it's one IP address, it's Anycast, one IP address, many places. So BGP is going to determine the best, you know, way to get there. But, you know, I can go ahead and give those IP addresses the higher weight, all right? And that works out really nice. And then I would just put the rest in like a normal priority, okay? And sometimes people will do that. And so when you hear weighted DNS, that's what it's talking about. Now, let's pretend, okay, I want to talk about Echo, all right? So I hit that, there's the IP address for Echo, okay? And if I come on down, oops, let me try this again. If I come on down, okay, then here in the list of all the root servers, you know, it starts with Echo, VeriSign's in charge of it, and we've got 16 sites, 16 colos. Now, inside that colo, there may be hundreds in each colo, and there's like a load balance, we've got load balancers in front of them. We don't know. But, okay, these are the IP, these are the different co-locations. Okay, so we might have multiple servers inside the colo. And if I look at Echo, okay, NASA is in charge of that one. We have lots of locations. So it just depends on who's in charge of each different root server, how many sites, because they're responsible for paying for all that. All right. And, okay. And, almost all of them are IP4, that's the green ones. IP4 and IP6. And then the brown ones are IP4 only. Okay, let me look at them. All right. And nice. Okay. So when I put in that Echo has a high, a high priority, and I put in that IP address, I'm trusting BGP not to send me to like Luxembourg. I'm trusting it to send to the Atlanta server. Can't find it. There you are. There's the Atlanta servers. Okay, my 2 Atlanta servers. And I don't have to worry about that part. Okay. So hopefully that answered a question too. I do see we've got one more in the Q&A. Did I already answer that one?
No. Question by Maya was, I came across in Windows AD environment that mostly serve type will have responses, no such name. Is it something to worry about or something to be fixed?
Well, the question is, do you have that service? So if you don't have, so like, let's say I'm looking for the LDAP server because I'm a Windows box and I'm gonna, no matter what, do you do Active Directory? Then you should have an LDAP server, and the IP address for that should be given to your domain controller. Sometimes people go ahead and, the domain controller does, all 3 of those things. It does, file services, and it does LDAP, and it does Kerberos. Sometimes they're separate servers. And so if I go ahead and I have that service, then I need to tell my DNS server that, so it can go ahead and respond. And if it's not getting those responses and you do have Active Directory, that's why. Okay, so you have to do it to the server.
At this point, Jerry reminds us that we have 5 minutes left. By the way, if somebody has a chance to get a news article or something about how the 8 main root DNS servers are updated on the internet, check that out. I'm looking for the article. I forgot it. I will send it on my Twitter page and to Betty afterwards.
Oh yeah.
That's an operation that's more difficult than Fort Knox, to be quite honest, because every main root server is protected by certificates which need a certificate chain authorization, and it requires at least, I think, 4 people from the INAA council to be present. Yes. And those 4 peoples are not allowed to travel on the same transport. They're not allowed to be in the same room at the same time, but within an hour. So those are some rules there that are really pretty difficult to apply to.
Very tight. Yeah.
And I think at least from the 8 panels, the main administrator, half of them have to be anonymous. So they are not allowed to be known publicly who is responsible for the servers.
Right.
So that's part of
the person who held the key for many years for DNS for the United States, because there's a couple people in different areas, like you said, geographically dispersed. The person who had the key here in the United States was Dan Kaminsky, and Mr. Kaminsky passed away maybe 2 or 3 months ago, very young, and so they had to go through the whole process of, all right, who's going to have the responsibility of that key for that. And I don't know if they've picked someone or who they picked, but I was very sad to see him pass away.
He was also a big IT security guy.
He's the one who actually discovered that the transaction IDs, because there's only 2 bytes on current computer systems at the time, because this was like back, I think, in 2010, 2011, something like that, could go ahead and generate enough different permutations fast enough to be able to go ahead and send the one that would work with a response, to the client, right? So we're getting, an answer that we think is matching up to this transaction ID. And of course, you'd spoof the source address. But what is happening actually in the data is sending you off to like weirdo freaky site. So he's actually who coordinated all of the, and I'm not actually saying this because Roland, you don't know, I'm actually saying it for everybody, because you probably do. But he's also the one who coordinated, getting Microsoft and, getting, the big companies at the time to go ahead, sit in a room, hash this out and not, report the bug, not publicly announce the bug until it got fixed. So for, a couple weeks. And so he's kind of amazing.
So listen to us geeking out about DNS. Who ever told anyone that network stuff is not interesting?
Yeah.
So
but I do have what else to check out, right? So we should do the CTF.
Yeah.
We should look at the sponsor pages, and as Saka said earlier today in the keynote, if you have a PCAP, and that you can go ahead and either anonymize using Jasper's anonymation Trace Wrangler. Sorry, for a minute, my brain went empty. Using Trace Wrangler, you can anonymize it enough that you feel comfortable giving it to us. Then, but there's some issue. And you want to see how 3 different people go ahead and deal with that, look at that trace file and try to find the issue, what their process is, because that's really what we're talking about. How do we do the process versus the actual issue in the packet? Then please send those to Jasper. That would be awesome. Otherwise, we're going to be very bored during this session. Okay.
And you might see somebody who hosted today.
Ooh,
but with that note, I have to say goodbye, everyone.
Great.
And I hope it was informative, and see you in the next one.
Thanks, Roland.